All right. Well, thanks, everyone. Good morning, and thanks for being here today. AI is quickly becoming the next big thing in enterprise IT, and I'm excited to be here today to share some of the things that NetApp has been doing in this space. My name is David Arnette, and I'm a principal technical marketing engineer for NetApp Solutions team. I've been in solutions engineering for about 6 years, and I've been focused on AI and machine learning and HPC for about the last 3 years. And before that, I spent about 15 years as a PS consultant installing storage systems for everything from 2-server VMware deployments up to the Lawrence Livermore Sequoia supercomputer that I worked on back in 2012. So over the next 15 minutes, I'm going to be talking about the workflows that customers are building and the challenges that they present. But of course, like everything these days, customers want an easy button, even for the most complex processes. So I'm going to be talking about how the portfolio of products that we have to offer can really make life easier for the IT teams tasked with supporting these next generation workflows. After that, my colleague Mike Oglesby is going to spend a few minutes talking about data engineers and data scientists can leverage the capabilities we offer to streamline their day-to-day work and provide the ability to turn freeform experimentation into reproducible and automated processes with important enterprise features like traceability and data protection of those critical information assets. So the first thing we have to understand is that the data is the most critical part of the AI development process. From this IDC research, we can see that that's where the challenge is as well, right? More than a third of the respondents feel that data management issues are what's holding them back. Traditional software development required that a human write a piece of code to enable the computer to transform some data into an output. Machine learning and deep learning techniques kind of turn that completely around and say that the human provides the output, labeled data, or what the final result should look like, and the computer writes the code that accurately produces that output from the input data. So that means that the quantity and quality of the data used is critical. And while an enterprise may have a massive amount of data in total, traditional application design means that the data is typically spread across countless different systems, databases, formats, you name it. So what I'm going to do is describe a workflow that is used mainly in autonomous vehicle development, but it really can apply across pretty much industry vertical, right? So the first phase is ingest, right? This is where data is generated. It happens at the edge, what I'm calling the edge, but that could be anywhere from a self-driving car collecting video and sensor data. It can be transaction data from an ATM or time series data from a manufacturing plant, or even something like telemetry data from a website, right? But depending on what that edge looks like, there's always different compute and capacity and performance requirements. For example, the self-driving cars, they can generate as much as 2 terabytes a day of data. And another medical researcher we've been working with is generating more like 10 terabytes a week. And then some of the financial use cases talk about 10 terabytes a year, right? So the requirements for the capacity and stuff can be very widely variable. But once that data is collected, it generally has to go somewhere. And the trend these days is object storage, right? Object storage is becoming a real standard here for a couple of reasons. One, because it's basically limitless storage. So you can put as much as you want out there as well as you're willing to pay for it. It's very easy for applications to speak S3, right? S3 is a relatively simple API type protocol. And it's also very easy for other processes to move data into a bucket like that if the application itself doesn't cover it. And for example, NetApp has a product called Cloud Sync that I'll talk about in just a minute that does exactly that. But the object storage generally typically has had some limitations, and that's generally around performance, right? Because typically when we're talking about object storage, we're talking about public cloud, and network performance is always a challenge there, right? And so you may have massive quantities of data out there, but how do you get to it in a quick and useful manner when it's out there? And also, how do you, one, it costs money to store it out there. And more importantly, it costs money to get data out of there. That medical customer I just mentioned, they pay $20,000 a month every 3 months to download a new big chunk of data. And so this is one of several areas where NetApp can really solve these problems. And even more importantly, enable workflows in a way that the public cloud object stores can't. So StorageGrid is NetApp's object storage platform. You may be familiar with it. It is multi-site by design, right? Like the whole point of this is to be able to manage the multiple places we're going to collect data from or see data. It has a lot of flexible hardware and software defined footprints. You can do all virtual nodes, you can do small scale flash appliances, or you can do up to petabyte scale spinning disk devices, and you can mix and match in any combination you want. StorageGrid ends up being cheaper than AWS S3 at multi-petabyte scale, right? So that actually brings some cost savings both in the storage itself, and then the fact that you're storing data on site without paying egress charges means you can potentially save a ton of money. But the most important feature here is the information lifecycle policies that enable incredibly flexible data management, right? So data ingested at one site can automatically be moved to one or more other sites. Cold data can be moved to archive tiers, or by using metadata tagging, data can automatically move through a workflow like we're talking about. And I'll hit a couple of examples on that as I get a little further here. These features really have led to pretty good adoption in EMEA because the data location can be so explicitly controlled and monitored or even remediated based on new regulations or business requirements. And the same applies to any kind of workflow where you might want to modify and or change the process slightly, right? So back to my workflow. Now we're talking about a object storage. It's not just any object storage, it's StorageGrid. And it's really the foundation for a data lake, which is a term that people have been throwing around for a while, but didn't quite fit some of the solutions that were using it. So the lake may be fed by streams coming from a single use case, like our autonomous driving workflow, or the data may be coming from every business unit in the company, right? Now that we've got data flowing into our lake, it's time to make some use of it. And that happens in what we're calling the data factory.
Hey, David. So it's Ray Lucchese. I guess the question is, the StorageGrid, does it really support, edge deployments, or is it more of a data center kind of deployment solution?
It supports any location where you can physically put the compute power and storage to run it. You know what I mean? There is, so like I said, you can run virtual nodes, so you could run it in a virtual footprint. It doesn't run, it does run as containers, but you still need the physical infrastructure to actually store data there, right? So it depends on what you mean by the edge. If the edge by the edge you're talking about in the car, probably not. If the edge you mean, the garage that the car pulls back into at the end of the day to offload the data, then absolutely.
I guess the question is, does it run on ARM solutions and MIPS solutions and things of that nature, or is it all, x86 server class devices?
I believe right now it's all x86 class devices, right?
Okay.
It does run as a container. I don't know enough about the roadmap for that to speculate any further, but it is right now on x86. Okay, so the data factory here, lots of things happen here. This is actually just like your average old data center, right? But it's tied together by the fact that both the data coming in and the data being used may be used by more than one process or more than one business unit, right? Some of the key tasks here are things like labeling and data set curation that generally require lower performance and may actually just use direct S3 access. But one of the other more challenging workloads here is things like normalization, right? You've got data coming in, images, they may be different sizes, they may be different resolutions. So before they can be used for an actual training process, they do need to be converted into a consistent format and things like that, right? And that ends up taking a lot of time and compute horsepower just to churn that data through in a process like that. And then the last thing that may happen here is things like analytics, right? A lot of customers are running analytics on things like Hadoop, and now Spark is becoming a lot more popular. The challenge there is Hadoop is kind of facing the end of its functional capabilities in terms of scale and performance, the only way to really make it effective is to make it bigger and bigger and bigger, which just creates all kinds of infrastructure challenges, right? So things like Spark and serverless computing are taking over for those kind of things, where users can run just the business logic they want and pick a pool of data like an object store and suck some of it in and run their tool and see what happens, right? So it provides a much more easy way for anybody who is interested in the use of this data to get access. So thinking about that XCP thing, this is another area where NetApp is working really hard, right? Like we've got a lot of good products, but they kind of do different things and they fill different needs. And this AI workflow really encompasses all of them. So we're working on tools like XCP here to enable high performance movement of data between the various data sources. Mike is going to talk about how all this can be automated with Apache Airflow, but the lower level goal is to simplify the movement of data into or out of the lake, so users spend less time doing things like that and more time being productive. Right now, XCP is focused on NAS and HDFS data sources, but S3 support is on the roadmap. And if you really need S3 support right now, we have this product called CloudSync that I mentioned that can basically use any public or private S3, SMB, or NFS source as a source or destination for automated movement of data, right? So we're really trying to provide a lot of the glue that ties these various functionalities together and make it as seamless as possible, both for the IT administrators as well as the end users. So these tools allow the customers to use any of the data sources they want in whatever way makes sense, whether that's for tiering or just kind of aggregating different sources. The other big value here is that they can continue to leverage investments in Hadoop, right? They've already spent a lot of money on servers and storage and built a Hadoop environment, and they can't get away from it yet until those assets are depreciated. So we're trying to provide a way that we can integrate all of those things without forcing big changes within the data center. So I kind of left my workflow for a minute, but it's this data factory stage that has the most variability in workloads. And it's important to understand how to accommodate those while still maintaining that centralized data lake. But once we get through all of that stuff, that's really where the heavy lifting happens, which is the training and validation phase. This is part of the process that has the highest performance requirements for both compute and storage. And the infrastructure here is generally dedicated to this purpose. So before I talk about that infra a bit more, I'll point out that the data gets here using some of those tools I've already talked about. Although direct S3 access is a thing, right? We've seen data scientists pulling data directly from S3. And now that we've released the storage grid all flash nodes, we can actually deliver some very high performance for a direct S3 access. So NetApp actually has two options for the training and validation infrastructure. One is the ONTAP flavor, since that's solutions we see most enterprise customers preferring. We've tested it with up to 8 DGX A100 nodes. That means you could put 12 pairs in an HA cluster and get up to 96 DGXs in a big compute cluster. And deliver 300 gigabytes of bandwidth and a single namespace of petabyte scale. We can also do things like build hybrid clusters, some hard drive and some SSD, and put really cost-effective tiering right next to the compute and use some of the internal ONTAP features like a vol move or a flex cache to accelerate data to an SSD when needed. We've always got the great features like snaps and clones that have been around forever, and they can be used in a lot of ways for workflow integrations like Mike is going to talk about. And you could actually build a data lake like we've been discussing on ONTAP only, using things like the native snap mirror and other replication features of ONTAP.
Yeah, so I do have a question. Are you selling then a solution, or you're just selling pieces like storage and then have your customer partner with NVIDIA to build the solution?
Yeah, we're working with our joint partners with NVIDIA to build the whole solution. We do have a roadmap for bringing that into a more kind of easy to purchase unified way. That's going to be kind of several months out, I think. But for right now, it is kind of a two-partner engagement to build this whole stack.
Right, and then you talked a little bit about the automotive market. Are you specifically targeting automotive, or you're just targeting multiple verticals and automotive just happens to be one?
Well, we are targeting specific verticals. Automotive happens to be one. The verticals we're targeting are automotive, healthcare, and retail and financial. I guess four that we're kind of primarily targeting. And so automotive was the first one. We've actually got a couple of white papers that we put out on an automotive validation, right? More specific to the AV workflow.
Do you see any future implementation of storage grid as the storage layer for this kind of solution? I mean, NVIDIA bought SwiftStack last year, and with the idea of building something around it. So,
well, I personally love the idea of using storage grid as the primary storage for this purpose. The problem ultimately is performance, right? The workloads that these GPU servers are driving generate, gigabytes per second per server, up to, as many as 5, 6, 7, 8 gigabytes per second per server. And typically, even with the all-flash nodes, we just can't support that with the object storage yet. Now, I've got on deck to test. We've released S3 as a protocol for ONTAP, and my understanding is that it's much faster because it is really a very shallow protocol translation to put it onto the disk, and so that might help as well. The problem there is that that's not really a part of that data lake that we're talking about. So performance is the limitation. I think as we get more performance out of the object stores, we'll start seeing it just go directly to the object.
So you see the workflow is transferring some portion of the data to the ONTAPs from storage grid to ONTAP, and then the training occurs off of the ONTAP solution? That's
correct, yeah, and that's what users are doing right now. I mean, like I said, the medical customer we spoke with last week, every 3 months they download 200 or 250 terabytes of data that's been uploaded to S3, right? They've got a lot of sites that are uploading data to S3, and in the data center every 3 months they download a big giant chunk, and then they train on that for 3 months, and then 3 months later they pull another chunk. And a lot of that has to do with the costs associated with it and the time it takes to do that, right? So something like storage grid means that as soon as that data hits the remote location, if the policy says move it to the data center, it starts moving, right? And it's there. And so it really kind of, one of the things we're really trying to eliminate is users running copy commands, right? There's no reason for users to waste time copying data. We can automate all of that.
All right, thanks.
And Dave, just maybe as a supplementary question to that then. So did you say that you're looking at supporting that same kind of thing now with the S3 capability in ONTAP?
Yeah, so S3 is available as a protocol in ONTAP. It is not really an object store, right, in the sense that it doesn't have all of the metadata. It's still basically putting data onto a waffle file system on our ONTAP system, but it is an S3 compliant protocol endpoint that you could use. Just like, hey, I need an S3 bucket right now, you could flip it on with ONTAP right now as a free available feature.
And so you think that could play part in this kind of workflow that you've described here?
I think it could in some ways, but I think it will maybe eventually when we get tighter integration into the storage grid, right? Like honestly, the thing I've been talking about and asking about is if we could do something like a flex cache for storage grid, right? Where you've got a big data lake and then you've got an ONTAP system and you just kind of cache that stuff locally in the ONTAP system. That way it's all invisible except for what's important as you're reading it and stuff, right?
Thank you. Yeah, it's interesting. Thanks.
Yeah, it is very interesting. So I'm going to move on real quick here. The other option we've got here is an InfiniBand option, right? So traditionally HPC type infrastructures, and there's a lot of people in this space who are looking for HPC type infrastructures. We can support that as well. We previously validated this on the DGX2 with IBM Spectrum Scale, and that is in the NVIDIA labs right now. We're validating again on the new A100 servers. Except this time we're using BGFS as the parallel file system. And we're actually working a lot with BGFS. BGFS is going to be the partner going forward, or the primary partner going forward for this type of solution. And in fact, we're currently working with them. You guys may have heard of the GDS, GPU Direct Storage capability that NVIDIA has come out with. And we are we're going to be supporting that with this right off pretty much as soon as all of this is available, I believe, and then potentially supporting it on ONTAP late this year. So I'm going to run on real quick here. The last step of this phase is model distribution and archiving, right? So once you've actually created some stuff, it ends up needing to go back out to the field. And this distributed object store provides a great way both to kind of redistribute that content as well as put it in a potentially protection mode.